Good morning. Today we will discuss organic chemistry practical in B.SC part 2. In previous class we discussed class determination. The properties of an organic compound depends on the type of the functional group present in it. The functional group may be defined as an atom or group of atoms which determines the chemical behavior of an organic compound. The detection of these groups is the most important part in the detection of organic compounds. Generally, the organic compounds have been divided in 7 types depending upon the element present. Type 1 compounds containing carbon and hydrogen with or without oxygen. Type 2 compounds containing carbon, hydrogen and nitrogen with or without oxygen. Type 3 compounds containing carbon, hydrogen and halogens with or without oxygen. Type 4 compounds containing carbon, hydrogen and sulfur with or without nitrogen and or oxygen. Type 5 compounds containing carbon, hydrogen, nitrogen and halogens with or without oxygen. Type 6 compounds containing nitrogen and sulfur. Type 7 compounds containing nitrogen and halogen and nitrogen and sulfur. So this is the classification of the class determination. Today we will discuss phenolic, OH, aldehyde ketone, etc. Now the phenolic group. This is an aromatic functional group. First test is ferric chloride test. To the aqueous or alcoholic solution of the substance, add drop of ferric chloride solution. A violet, blue, green, red or reddish brown color appears. The reaction is C6H5OH plus FeCl3 gives violet color. Di and trinitrophenols, meta and para hydroxybenzoic acids, tribromophenol do not produce characteristics color with FeCl3, while alpha naphthylamine gives a blue color with FeCl3. Second test is Lieberman-Nitroso reaction. Fuse the compound with a crystal of NaNO2 in a test tube. Cool the content and add 1 ml of concentrated H2SO4. A dark green to blue solution is formed which turns red when poured in the water. If NaOH is added to this solution, red color becomes again dark, green or blue color present. Note: hydroquinone, nitrophenyl, hydroxy acids, catechol do not give this test. The reactions are C6H5OH in the presence of HNO2 gives para-nitrosophenol. Para-nitrosophenol in the presence of C6H5OH gives indophenol. The color is red. Indophenol reacts with H2SO4 gives green color. Indophenol again reacts with NaOH gives blue color. So this is about the phenolic group. The reactions are ferric chloride test, Lieberman-Nitroso reaction. From these two reactions we can determine phenolic group. The second group is carbonyl group. The reactions are 2,4-dinitrophenylhydrazine test. Second is tolerance reagent test, Fehling solution test. First is 2,4-dinitrophenylhydrazine test. When aldehyde and acetone condense with 2,4-dinitrophenylhydrazine, yellow-orange crystalline hydrozones are formed. In a test tube, add few drops of the liquid or its alcoholic solution to reagent and few drops of concentrated H2SO4. Heat and shake vigorously and then allow to stand for 5 minutes. A yellow-orange PPT is obtained, which confirms the presence of carbonyl group. Test for aldehydes. First test is tolerance reagent test. To the reagent, add 2-3 drops of the substance and heat on water bath for about 5 to 10 minutes. A grayish black PPT or silver mirror obtained. Reducing sugars also give this test. Second test is Ferric solution test. Mix Ferric solution A and B and to this clear blue solution. Add few drops of the substance and heat. A red-brown PPT confirms the presence of aldehydic group. Aromatic aldehyde do not give this test. When CuO reacts with RCHO, it gives Cu2O's red PPT. Christmas test. Add a little of the substance to 2 ml of Nestler's reagent. Red, brown or black PPT is obtained. Third test is Schiff's solution test. Add few drops of the liquid or 0.2 gram of solid compounds to 2 ml of the reagent. Shake vigorously and wait for a few minutes. A deep red or violet color confirms the presence of aldehydic group. Never heat the content during the test. Another test for ketone. If a compound fails to give aldehyde test and contains carbonyl group, then the compound will be a ketone. First test is sodium nitroprusside test. Add compounds to 2 ml of 10% aqueous sodium nitroprusside solution and make it alkaline by adding few drops of NaOH solution. A wine red color changing to yellow confirms the presence of COCH3 group. Another test is Metadie Benzene test. In a test tube, mix finely powdered Metadie and a small quantity of the substance. Add excess of NaOH solution. A red or violet color appears, which fades on standing. Benzophenone does not respond to this test. Now another test for carbohydrates. First test is Smallish Test. To the aqueous solution of the substance, add 2-3 drops of 10% alcoholic solution of alpha-naphthol and shake. Now add carefully 1 ml of concentrated H2SO4 along the side of the test tube. Reddish violet ring is obtained at the junction of two layers on shaking. The whole solution becomes violet red with a blue precipitate. This test is highly sensitive and even the fiber of the filter paper respond this test. Another test for carbohydrate is tolerance reagent test. In a dry test tube, add tolerance reagent to the compound and heat on water bath for about 5 minutes. A silver mirror or grey PPT confirms the presence of carbohydrate. This test is only given by reducing sugar. So this is all about carbohydrate, ketone, aldehyde. carbonyl groups, phenolic groups for class determination. Thank you.